For those of you who weren't in class the other day, I just wanted to briefly go over lesson 5. So the point of this is to understand about how we categorize some of our elements. The first thing that we did, and we did spend time going through these movies, and you can watch them if you like on the class video, is really sort of to test some different properties of elements. So we took a variety of elements. We took aluminum, carbon, iodine, magnesium, silicon, sulfur, and zinc, and we tested a bunch of things about them. We looked at them in detail. We tested their conductivity. We tested whether they were malleable. That is, if you hit them with a hammer, do they bend rather than break? We tested if they reacted with hydrochloric acid and with copper chloride. And when we finished, we ended up with this table of properties. Notice that I'm going to ask in a second to look at it and sort of say, is there different types of patterns, different types of elements within theirs? And hopefully you can see that we have a couple of different types. First of all, we're asked about what's the difference between a physical property and a chemical property. And a physical property test is one that's testing something that's going to be doing just physical changes. So the appearance, the conductivity, the malleability. And then we also have chemical property tests, like testing, does it react with hydrochloric acid and does it react with copper chloride? Now, it says to sort them into two groups based on their physical and chemical inner properties. And as we do, notice that we kind of have these type 1, where everything's a yes. They're metallic in appearance, and they're conductive and malleable, and they react with both hydrochloric acid and copper chloride. So we have aluminum, magnesium does the same, and zinc does the same. And then we have another type, and that's the ones that are the no's. They're not conductive, they're brittle, they don't react with either reagent, and they may be a little bit shiny, but they're not like the metallic kind of shiny. And that would be carbon and iodine and sulfur. And then we had one that kind of didn't fit either pattern. Notice that it was conductive and it was a little bit more silvery, so it did have a little bit more metallic color to it, but it was not malleable and it did not react. And so from that, we want to talk about two things. Sometimes we talk about a chemical property called reactivity. And reactivity simply means, is it able to react with a particular substance? And the other thing is to really talk about how we're going to classify elements into one of 3 categories: metals, nonmetals, and metalloids. Primarily, it's really metals and nonmetals. So metals are shiny, they're conductive, they're malleable, meaning that they can be bent and shaped into different shapes. They're high density and high melting points. They often react with acids and with copper chlorides. And nonmetals, on the other hand, are dull, poor conductors of electricity and heat, brittle solids, and tend to have low density melting points. And then we have the metalloids, which have properties of metals and nonmetals. So they could be shiny or they could be dull. They may be malleable or they may be brittle, but they do tend to conduct electricity. Generally, they conduct them better than nonmetals, but not as well as metals. So beyond that kind of classification, there's other classifications we can find. And so at this point, I've got some element cards I'll show you in a second. And the idea is to first sort them into metals, nonmetals, and metalloids, and then look for another way to sort them. And I'm just going to briefly go through these. You can come back and rewind. Note that we start with our metals, nonmetals, and metalloids. So of the metals, the only ones we really can do a further sort on is the metals, because we have 6 of those, whereas we only have 1 nonmetal and metalloids. And so I'm going to show you a couple of different classification schemes. In some case, the first sort is based on metals, nonmetals, metalloids. In other cases, it's based off of something else. And, this would be an exercise for you to practice as well. So one way I could after I could sorted it by metals, I could then sort the metals in terms of increasing atomic mass. Another option is to look on there, and even if I don't know what it is, I can see that the first sort I could use is combining power. There was a category on those cards that had combining power, and I could kind of combine them by ones with combining power 1, 2, 3, 4, and then within those piles, sort them in terms of increasing atomic mass. Another option is to sort it by reactions. So the first sort would be, does it react with water or oxygen or does it not? And then sort it by atomic mass. In conclusion, there's several ways you can sort the elements, and the idea is to understand that we're going to adopt a particular sorting pattern, and it's known as the periodic table. Giving you a little background, the periodic table was sort of created in the late 1800s based off of sort of a century worth of work of scientists organizing elements based on trends and grouping of properties. So they had already been collecting a lot of this information, and in the late 1800s, Dmitri Mendeleev sort of organized it into this sort pattern. His table predicted the existence and property and reactivity of elements that had not been discovered. And that made it a particularly powerful one. Once they realized that his predictions came true, they found that this could be very helpful for going after and looking at what particular experiments to do to sort of detect new ones. And our basic modern periodic table is organized on a model of atomic structure, but of course at that time they didn't know the atomic structure. So just kind of wrapping up, if I told you about germanium and said that its appearance is grayish white, shiny, metallic, that it was slightly conductive, that it was malleable, means it could bend if you hit it with a hammer as opposed to brittle, and it did not react with hydrochloric acid, and it did not react with copper chloride, would you classify that as a metal, a nonmetal, or a metalloid? I'll give you a second. So hopefully you answered metalloid. So when we look at the shiny metallic, that's a metallic property. And we look at the conductive, that's a metallic property. And we look at malleable, that's a metallic property. But non-reactive with hydrochloric acid and copper chloride are nonmetal properties. So it has some metal properties and some non-metal properties. Therefore, we classify it as a metalloid. And that's the end of lesson 5.